Welcome back. My name is Satyajeet Sahu and we are in our champion series. Okay, so if you are able to hear the audio nicely and the video is clear to you, just once write okay in the comment section. If everything is clear, then we'll start the class. Okay. So good evening Anu, good evening Vivek, good evening Harish, good evening Nikki, good evening Karthike, good evening. Yes, audible, everything is clear. Others also? All okay? Let us start the lecture. My name is Satyajeet Sahu and we are in champion series, and in champion series we are going to see what? Foundation engineering today. Okay, so in foundation engineering, can you name some of the important topics? I request all the students, okay? Can you write some important topics? Okay, then we will start the class. Okay, please write the important topics which you feel are important in foundation engineering. Let us discuss them and then we'll go to solving the questions. Please write in the comment section. I'm reading the comments. I have to see this side. I am seeing this side because I have placed the comments laptop here. Please write the important topics which you feel are important in foundation engineering. Yes. Yes, Karthik is saying bearing capacity of soil. Yes, bearing capacity. Vivek, okay, okay. Others, what are others doing? Others are sleeping. Everyone, please contribute. Deep foundation, water table in soil. Okay, okay. Pile foundation. Very good, very good. Let us start with our bearing capacity. So today is the last lecture of Geotech, and then other lectures also will start: surveying, steel structure, transportation, and hydrology irrigation. These are the days. Okay. Subscribe to our YouTube channel and also the Telegram group, link mentioned in the description. Okay. Please subscribe to the YouTube channel and also get connected through the Telegram group. Then you'll get the notifications of the classes, right? So that you don't miss any important class. Okay. Now, let us start with what? The bearing capacity of soil. We start with what? The bearing capacity of soil. So, the bearing capacity of the soil is the stress at which the soil fails, okay, in shear. Okay, the soil fails in shear. The bearing capacity of soil. Okay, so normally we use this term for what? Our shallow foundations, right? Now, what is shallow foundation? As per Terzaghi, the shallow foundation, the foundation in which the depth of the footing, right? The depth of the footing will be less than the width of the footing. The depth of the footing is what? Less than the width of the footing. In that case, I will say what? It's a shallow foundation. It's a shallow foundation. So how to find out the ultimate bearing capacity? Okay, at the base of the footing. Okay, at the base of the footing, how to find out what? The ultimate bearing capacity. Now you know the formulas, but still I will just tell the formulas and then we will be moving into what? The questions. So the ultimate bearing capacity of soil. The ultimate bearing capacity of soils. Of soil, you can say the soil below the footing at the base, you can say like that. Yes. So this particular ultimate bearing capacity has three components, right? The first term is what? C and C. Okay. The second term is what? Q and Q. The third term is 0.5 B gamma and gamma. Okay. So here let us see what are the terms used. The terms are, you see, there are three terms. What is NC, what is NQ, and one is what? Your N gamma. Now these three are bearing capacity parameters which depend on the angle of internal friction phi. Okay. So this is what? C is your cohesion. C is the cohesion. Okay. And what is Q? Q is the surcharge. That is what? Gamma of soil into what? DF means what? Depth of footing, right? In the earlier slide, we have seen depth of footing DF. Very good. Now, the next is what? 0.5 B gamma. B is what? Again, the width of the footing. The width of the footing. Now this equation is for what? This equation is for your strip footing. It is equation is for what? Strip footing. Now what is a strip footing? Strip footing is a particular type of footing. It's a rectangular footing basically, where the length is quite large compared to the width. Okay. So now how the equation will change for different shapes of footing. That is very important. First point important is what? How the equation change for different shapes of footing, and how the equation change when we are seeing what? Either purely cohesive soil or cohesionless soil. Let us first see the effect of shape. So this is for a strip footing. Now if you are seeing the other shapes, what can be the other shapes? Please mention in the comment section. What can be the other shapes? Please write in the comment section once. What can be the other shapes of footings? Let us see that you are aware of that or not. Okay. And also to engage the audience, right? Yes. The class should be interactive where we are discussing together. Okay. So please mention in the comment section what are the different shapes which are found in footings. Yes, Karthik is writing square, circular and rectangle. Very good. Square, circular, rectangle. Very good. Okay. So first of all, let us see what effect is had on square footing when we have a square footing. So when we have a square footing, okay, what will happen? The first term will change. Okay, the first term will change. Okay, the first term will become what? We will add a coefficient 1.3 C and C. Okay, so you can see that this 1.3 is the coefficient added. Plus second term remains unchanged. The third term changes. Instead of having 0.5, we use what? 0.4, then B gamma and gamma. So you can see that compared to the original equation of what? Your strip footing, there are two changes. One change is this 1.3 here, and one change is instead of 0.5, it become what? 0.4. Okay. Now for circular footing, you can remember that it is quite same as what? It's quite same as the square one with a minor difference. What is the same? Or what's the difference? It is 1.3 C and C plus Q and Q. Then in place of 0.4, we are having what? 0.3 B gamma and gamma. And here, see, in case of square or in case of what? Your strip footing, we have a width, right? But in case of your circular, we don't have a width. We have what? Diameter. So in place of width, I will write what? Diameter. So you can see that compared to the square, only one change become what? 0.3. Now we'll write the equation for rectangular, and from the rectangular we'll see that we can remember all the equations. Yes, in GATE we have to be smart, right? If you're appearing for GATE examinations and other competitive examinations, actually in any competitive examination, you need to be smart. And what is the smartness? The smartness is that you remember one equation, and from that you can write many other equations. So for a rectangle, I can say the equation changes to QU is equal to your 1.3, no, it is 1 plus 0.3 width by length. See, a rectangular shape footing will have two dimensions, right? It will have a length, it will have a width. So 1 plus 0.3 B by L, okay, then C and C, okay, plus Q and Q, okay, plus 1 minus 0.5 B by L, and then 0.5 times of this, then B gamma and gamma. So this is the equation for finding the ultimate bearing capacity for a rectangle. Now how to find out for other shapes? Very easy. See, in case of square, what will happen? Tell me. In case of square, what will happen? B will be equal to L, right? Yes. B will be equal to L. So I can say what? I can say that B by L is equal to 1, right? B by L is equal to 1. If B by L is equal to 1 in this equation, what will happen? This will change to what? 1.3 C and C, right? Yes. It changes to what? 1.3 C and C. Yes. And then the second term remains same, Q and Q. The second term remains same, Q and Q. Now see the third term. Now B by L is 1. If you put here 1, what will happen? 1 minus 0.2, which is how much? 0.8. And 0.5 per 0.8 is how much? 0.4, na? Yes. 1 minus 0.2 is 0.8. 0.8 into 0.5 is what? 0.4. So this becomes what? 0.4 B gamma and gamma. You see? So if you know for the rectangle, you can find out for square, right? If you know for rectangle, you can find out for square, right? Smart. Now you see, you can find out for strip also. How? You see, for a strip footing, what will happen? For a strip footing, I can say the length is quite large to the width. That is the definition of strip footing, right? And I can say that your length is very large, so B by L will be almost 0 or a very small value. I can take it as 0. So in this equation of rectangle, put B by L 0. So what will happen? 1 plus 0.3 into 0 will give me what? 1. And the equation changes to what? Only C and C, right? Yes? Yes. And then you see second term is unchanged. And when you see the third term, if B by L is 0, so what I can write? 1 minus 0.2 into 0 is what? 1 minus 0? 1 minus 0 is what? 1, and 1 into 0.5 is 0.5. So I get back this original equation. So like this, if you remember the rectangle, you can remember for any shape, right? So this is the effect of shape on the ultimate bearing capacity we saw. Now, before solving the question number 1, some more important inputs. Okay, what are the important inputs? The important input is the cohesive or cohesionless. Let us see. If you are seeing a cohesionless soil, then what will happen? C is 0. If C is 0, the first term will vanish now. The first term will vanish. And the ultimate bearing capacity will be only Q and Q plus your whatever. If it is square, so it will be 0.4. If it is strip, then 0.5. If it is circle, then 0.3. Let me write for strip footing. So 0.5 B gamma N gamma. Now this 0.5 will change as per what? The shape, right? Now this is cohesionless. If I write it is cohesionless and depth of footing is 0. Yes, if this is the condition, depth of footing is 0 means what? It is placed at ground level, right? When I say depth of footing is 0 means what? Placed at ground level. So if it is placed at ground level, what will happen? DF is 0. And what is Q, by the way? Q is gamma DF, right? We have seen Q is what? Q is your gamma DF. So if DF is 0, so Q is also 0. Yes. So Q is 0. Q is 0 means what? Second term also vanish. And I am left with what? Q is equal to what? 0.5 B gamma N gamma. I can write this for what? Strip footing. It will be equal to 0.4 B gamma N gamma. This I can write for what? For a square footing. And this will be same equal to 0.3 B gamma N gamma when I'm writing for what? I'm writing for a circular footing. Yes. So you can see that if in the question they are writing, that soil is cohesionless and the footing is placed at the ground level, then I can say that we will be left with these equations. This is what? Cohesionless, and if the footing is placed at the ground level. Very good. Let us see when it is what? Purely cohesive. So when it is purely cohesive, what happens? Phi is 0. Purely cohesive means what? Phi is 0. And as per Terjagi, the gentleman who proposed this theory, okay, there are many gentlemen, we'll see one by one, but the prominent gentleman is Terjagi. So he told what? He told that when phi is 0, then NC is equal to 5.7 and NQ is equal to what? 1. Yes. And N gamma is equal to 0. Yes. See, in this discussion, when I'm discussing these things, right? When I'm discussing these things, I'm actually revising many of the concepts, right? And I'm discussing many of the objective questions also, which can be asked in SSC JE, state AE, even in GATE examination, and even they can ask you 1 mark numerical also. See, later on we'll solve numericals of 2 marks, but in discussion I'm covering many of the short questions, right? Okay. So now you see, this is the NC is equal to this, NQ is equal to this, N gamma is equal to this. Yes, very good. This is for what? Purely cohesive soil. So you see N gamma is 0. When N gamma is 0, the third term will vanish, right? The third term will vanish and I will get QU is equal to only Q. NQ is 1, so I get only Q. Q plus what? Q plus your only, I will get NC, and NC will be 5.7. So 5.7 C plus what? Only Q. Because NQ is 1 and N gamma is 0, third term vanishes. Now, QU is what? QU is your ultimate bearing capacity. There is something known as what? Net ultimate bearing capacity. Is something known as what? Net ultimate bearing capacity. And net ultimate bearing capacity is Q and U and this is equal to what? It is equal to QU minus small q, right? So in this case, what will happen? If I put for purely cohesive soil this condition and find out the net bearing capacity, it will be 5.7 C plus what? Q. You see, this is a QU and then minus Q. So what happens? This also gets cancelled. I get what? Only 5.7 C. Yes. So we can remember this fact that the net ultimate bearing capacity of purely cohesive soil, is simply what? 5.7 Ch per Tejagi. This is for strip footing. This is for what? Strip footing. If I am using what? Square footing. If I am using square footing, then what will happen? I have to multiply 1.3, right, to this 5.7. How much I am getting this? I will be getting somewhere around 7.41 C, right? Get somewhere what? 7.41 C. Okay, and same for what? Circular also. Same for what? Circular also, right? So using all these things which I have taught you now, okay, using all these things I have taught you now, let us solve some questions. So questions time, right? Let us solve some questions, okay? So question number 1, yes, we can see that a footing is given and they asked what? Total safe load. Okay, how to find out load? See, the bearing capacity, what I told, it is a shear stress at which soil fails, right? It is the shear stress at which soil fails. So that means the bearing capacity is actually a stress. The bearing capacity is what? Actually it's a stress. So if it is a stress, then how to find out the load? Just multiply the area of the footing. Yes. So let us find out the bearing capacity, okay, and then find out the safe load. Okay, very easy question, but they will ask such questions. And remember one fact, that in the examination always they are going to mention what? This NC, NQ and N gamma. They will not mention when it's a purely cohesive, because in the purely cohesive, you should remember that NC is 5.7, NQ is 1 and N gamma is 0. This is only for what? Purely cohesive. Okay, but they will not mention if they write purely cohesive. They expect that you should know these values. But if we have some other phi, means phi is not 0, in that case, they will give the NC, NQ and gamma. You did not remember the formulas. See, there are formulas for NC, NQ and N gamma also, but they are not asked in the examination, so we should not study them and waste our time, right? Okay, so let us solve this question. Good evening, Aptab. Okay, let us solve this question. So in solving this question, first of all, we'll find out the ultimate bearing capacity. So here I will find out ultimate bearing capacity will be equal to, see, if nothing is mentioned, you will assume which footing? If nothing is mentioned, you will assume which footing? If nothing is mentioned in the question, then what you will assume which footing? Tell me. Nothing is mentioned, you'll assume which footing? Very good, strip footing. Assume strip footing. So it will be C and C plus Q is gamma dF into NQ plus your 0.5 B gamma and gamma. So everything is given, just put the values and give me the answer. You see, this is the cohesion given, NC is given, right? Then gamma is given, DF is given, depth of footing, right? Then width of footing is given, right? Gamma is given, N gamma is given, NQ is given. So everything is given. So ladies and gentlemen, please give me the ultimate bearing capacity. Please give me the ultimate bearing capacity. The first easy question, then we'll start with a little complicated one also, logical one, aptitude one. So ultimate bearing capacity of soil. How much are getting others? Okay, almost everyone found out the answer. Very good. The ultimate bearing capacity of soil I am getting how much? 1843 kilonewton per meter square. 1843 kilonewton per meter square. Getting how much? 1843 kilonewton per meter square. Very good. Now, from here, I'll give you some formulas, which you know before also, but I'll expect that you don't know. Not expect, I assume that you don't know. So the net ultimate, this is what? Net ultimate. Now net ultimate bearing capacity, how we find out? From the ultimate one, subtract what? Gamma dF or Q or gamma dF, subtract this. So you'll get how much? You'll get 1843. Gamma is your how much? Gamma is given 1.4. Okay, 1.4 and DF is given how much? DF is given 1.4 and gamma is given 18. So how much I'm getting? Tell me. How much I'm getting this net ultimate? Tell me. How much I'm getting this net ultimate? Please tell me in the comment section. So all of your very seriously studying for the examination. I'm very happy. So please give me the value of your net ultimate bearing capacity. Okay, 1817.7. Others also, please tell. Yes, others also contribute. So it is 1817.7. Very good. 1817.7 kilonewton per meter square. This is the net ultimate. The next term is what? The net save. NS, net save. Now what is the net save? The net save is the net ultimate divided by what? Factor of safety. Net ultimate divided by factor of safety. The factor of safety is given as 2.5. So 1817.7 divided by 2.5. How much I am getting? Tell me. Come on, tell me the answer. Very good student, 727.1. So all the serious aspirants of GATE are seriously studying for the GATE examination. Yes, and I'm very happy for that. Okay, so net safe also we got. The next thing is what? Question number 2, but before that let us solve this question. The next one is the safe bearing capacity. The next one is what? Safe bearing capacity. And how you find out the safe bearing capacity? Very good. Net safe plus gamma df. Net safe plus gamma df. That is how much? 727.1 plus gamma is 18 and df is 1.4. So how much I am getting this? That safe one, the safe one. It's a very basic question. We started with very basic questions. We'll move on to complicated questions one by one. Okay. We'll not go into complicated questions. Okay. We're not going to complicated questions. Means GATE level questions, I can say. Okay. There is no use of solving complicated questions. Okay. So answer is 752.3. Answer is 752.3 kilonewton per meter square. Very good. Very good. Okay. Others also find out. Okay. So I'll just revise. We know the formula for Q, right? From Q, how to find out Q NU? Just subtract what? Minus gamma df. And from NU, how you will find out NS? That is Q NU divided by factor of safety will give me what? Q NS. Yes. And from NS, how to find out QS? Just add what? Again gamma df. Yes. So this is the story of what? The story of ultimate bearing capacity, net ultimate bearing capacity, and then what? Net safe bearing capacity, and finally what? The safe bearing capacity. Now in the question they have asked what? They have asked what? The safe load. So the safe load will be what? The safe load will be equal to the safe bearing capacity into the area of footing. So what is the safe bearing capacity we got? 752.3. Now the area of footing. Now they have given what? They have given the width as 3 meter. They are asking you the force, load per unit length of the footing. Unit length means what? Length is 1. So length is 1 and width is 3. So area will be what? 3 only, right? Length is 1 and width is 3. So area will be 3, length into width. Yes. And then I'll multiply 3. So how much I am getting? Tell me. What is the safe load I am getting? Now you see this is kilonewton per meter square, right? You see this is kilonewton per meter square and the area is in meter square. So I'll get in what? Kilonewton. So what is the answer? Tell me. The answer is 2257 around, right? So this is a very easy question, okay, which they can ask in the GATE examination. But yes, you need to know the formula. You need to know the formula. But okay, now if they have asked you in the examination, suppose they have asked you the net safe load, okay, if they asked you net safe load, then what would have done? Then I multiplied this net safe bearing capacity, okay, multiplied what? The net, this 1 second, okay, then multiplied this net safe bearing capacity into the area, and the answer would have been how much? 2181.3. okay. So as per the question you find out the answer. Write down what? Net safe load, the net safe bearing capacity into area. Safe load, yes, safe load means what? Safe bearing capacity into area. Understood? Okay, very good. Ultimate load. Okay, sir, we should mug up the formulas of safe factor. Safe factor, no. If in Mayor of equation, in Mayor of theory, which is coming up, we will teach you. In Merov theory, if they give, they will give the inclination factors, the shape factors, okay, so no, and depth factors also. So no need to mug up those formulas. They will become too heavy for GATE, okay. Or one thing they can do is in the examination that they will give the formulas and tell you to use the formulas. So if they give the formula, then very easy, right? Okay. Either they will give the formulas for Merov, okay, or they will mention the factors, the depth factors, inclination factors, okay, and the shape factors. So no need to remember, okay. Understood, Jivan? No need to remember. Okay, very good. Let us go to the second question. The second question is little good. Now we are going to GATE level questions, okay. Listen to what? The bearing capacity. First, whenever they ask a question, let us read the question fully. Let us read the question fully. The bearing capacity of cohesionless soil means what? C is equal to 0 under a square footing, right? Square footing, okay, underline the square footing, width of 6 meters. So width of the square footing is 6 meter, and then the ultimate bearing capacity I am getting is 600 kilopascal. They are asking the decrease in bearing capacity if it is replaced by a rectangular footing of same area but width 4 meter. That means we have two footings, okay, we have two footings. And it is written both footing are placed at the surface. Placed at surface means what? df is equal to 0, right? Or I can say q is equal to 0, okay? Use Terzaghi theory. So when they ask a question like this, a comparison question, okay? Remember that whenever in the GATE examination, not only for Geotech, for any kind of subject, if they're asking a comparison question, what you do? First you write both the cases separately so that you can distinguish. So first thing is what? The first thing is square, okay? The second thing is what? Rectangle. Very good. So for the square it is written what? The square is written what? Width is 6 meter. Very good. Width is 6 meter. Now for the rectangle, width is given how much? Width is given 4 meter. Now what will be the length of the rectangle? Can somebody tell me? What will be the length of the rectangle? Please tell me. Please read the question and tell me what is the length of the rectangle. I'll have some water by that time. Read the question and tell me the length of the rectangle. Very good, very good. So it's in same area. Now the square area will be what? B square, 36. So I can say length into width will be how much? 36. And length is, the width is 4 meter, it becomes what? 9 meter. Okay, very good. Now, can you give me the formula for this? Yes, the formula for the square footing will be what? See, C is 0. So first term vanishes. Q is 0. Second term vanishes. So left with what? Only the third term, right? Cohesionless soil and placed on what? On ground means what? First and second term vanishes. So remaining is what? Square footing. So means what? 0.4 B gamma N gamma, right? And this is given how much? This is given as your 600 kilopascal. Very good. Now, when we write for the rectangle, what was the formula? The formula was 0.5, right? 0.5. Then 1 minus 0.2 B by L, right? Then B gamma N gamma. Very good. Now, can you reduce this and tell me what will be the coefficient? Can you reduce this and tell me what will be the coefficient in this case of rectangle? What will be the coefficient? B is 4 meter, L is 9 meter. Can you give me the coefficient? Please give me the coefficient. It will be actually 0.2 into B is 4 divided by 9. Then 1 minus that particular thing into then 0.5. Yes, I'm getting 0.455. I'm getting how much? 0.455. I think you also might be getting this value, 0.455, right? Yes. So I can say now that for square footing, I am getting QU is equal to 0.4 B gamma N gamma is equal to 600, right? And for the rectangle one, I am getting how much? I am getting 0.455 B gamma N gamma is equal to, I don't know. I have to find out that, right? Let me take that as X. So whenever you have to have two conditions like this. Never, find out this gamma and gamma nothing. Take what? Ratios. Take ratios. If you take ratio, what will happen? Right? For circle 0.4 B gamma N gamma divided by what? For the rectangular one, 0.55 B gamma N gamma. And this becomes what? 600 by X. Right? You see gamma and gamma gets cancelled, right? Why? Because you see the soil is same. Footings are different, but soil is same. Means angle of internal friction will be same. So, and gamma will be same. So, N gamma also is same, right? Why I am not able to cancel the width? Because for the square one, the width is how much? 6 meter. For the rectangular one, width is 4 meter. Now, can you give me X? Or I can say the ultimate bearing capacity of the rectangular footing. Can you give me X? Very easy question, you see. How much I am getting your QU for your rectangular footing? Tell me. 455 we'll get a lesser value, right? You can see we'll get a lesser value. Okay, solve it properly. I'm getting 455.56. I think you have taken the reverse one, I think, right? Taken the reverse ratio. Okay, let me just solve it. I think it is 600. Let me recheck the values. 600 into 0.455 into 4. Okay, divided by 0.4 divided by 6. Yeah, I'm getting 455. Okay, please recheck the calculation. Okay, so I'm getting this as 455. So you can see that when the square footing was placed, the bearing capacity was 600, right? When the rectangular footing is placed, it is how much? It is 455.55. So I can see there is decrease, and they have asked what? Decrease percentage. They have asked what? Decrease percentage. So now I can easily find out decrease percentage. I can say that the decrease percentage will be equal to how much? The decrease is how much? It is 600 minus 455.5 divided by the original one, right? Always divide by the original one, which is how much? 600 into 100. I'll get a close value close to 24% or 24.1%. Everybody understood this type of question? Yes. In GATE examination, they will be asking you this kind of questions, okay? In GATE examination, they will be asking you this type of questions, which will be very aptitude oriented. They will mix the concepts of your, you can say, core syllabus of Geotech or any other subject, right? And they will form some aptitude question. No, it depends on data. It depends on data. Many things are there. We can't say, right? They have written decrease means they have given you a hint that your values would come less. Yes. See, when they have written decrease, actually it is helping you in the calculation, right? But it's not, there is no rule for that. As per data, it is coming, okay? So question number 2 is over. Hope you enjoyed this particular question. Let us go to the next question, okay? Okay. This question is interesting, but I will explain the concept behind it, okay? I'll explain the concept behind it, and a lot of questions are asked from this particular topic. So first of all, let us see what is written. The ultimate bearing capacity of a footing placed on a cohesionless soil when the water table is at ground level. Okay, so suppose this condition, this is the footing, and water table is at ground level. If water table is at ground level, then what I can say? Here the soil will have unit weight of gamma submerged, na? Here the soil will have unit weight of what? Gamma submerged. Okay, okay, yes, and cohesion is 0. By the way, cohesion is 0. Very good. So what will happen here? What will be the ultimate bearing capacity? The ultimate bearing capacity will be equal to, I can say, gamma df. The gamma df will be gamma submerged into df into nq plus, suppose a strip footing. So 0.5 b, then what? Gamma submerged into b into n gamma. Yes, this will be the ultimate bearing capacity when the water is where? Is at the ground level. Now, when it is lowered to a great depth, yes, it is lowered to a very great depth. When it is lowered means what? Now the water table is very below the ground, the footing level and base means what? Somewhere here it is, okay? So it's not affecting the ultimate bearing capacity. So when it's not affecting the ultimate bearing capacity, I can say your QU will be how much? Now the soil won't have gamma submerged, na? It will have general gamma. It can be dry unit weight or it can have some amount of what? Water and suppose some bulk unit weight, okay? But mostly it will be dry. Mostly it will be what? Dry, because the water has come down due to lowering of water table. So it will be what? I can say gamma D. So gamma D into DF into NQ plus 0.5 B gamma D into N gamma. Yes. So if you compare these two conditions, right? When you compare these two conditions, everything is same, na? You see? If you compare these two conditions, I'll just remove this B twice I've written. Everything is same, na? You see? Everything is same. What is different? Tell me. What is the thing different? Tell me. If you compare these two equations, what is the difference? Tell me. Come on. If you compare these two equations, one is water table is present at ground level. Water table is present at ground level. Okay. Other case is what? Water table is present at ground level. Okay. And water table at great depth. Tell me, what is the major difference you are seeing in the equations of ultimate bearing capacity when COSI is 0? Please write down. Don't tell yes or no. But tell me what is yes. As Harish has rightly pointed out, the difference is gamma. The difference is what? Gamma. So I can say this is case 1, suppose this is case 2, right? I can say that for case 1, I am getting how much? I can take gamma submerged common, right? I can take gamma submerged common and I will get what? DF into NQ plus 0.5 B N gamma. And for the second case, the ultimate bearing capacity will be how much? Gamma submerged, no, gamma D into DF into NQ plus 0.5 B N gamma. So you can see that in both the cases, gamma is the major difference. If I take this as suppose some constant, suppose I am taking some constant, alpha, suppose I am taking some constant. If the soil is not changing, footing is not changing, then it will remain constant, suppose alpha. This is also alpha. So you can see here it is what? Gamma submerged into alpha, here it is what? Gamma D into alpha, some constant, okay, some constant value. So now what happens? You see, gamma submerged is approximately equal to what? Gamma D by 2. Gamma submerged is approximately equal to what? Gamma D by 2. Not exactly equal, I can say approximately equal to gamma D by 2. Yes? See, what is gamma submerged? Gamma submerged is gamma saturated minus gamma W. Now what happens, you see, normally saturated unit weights fall in the range of 21 to 19 to 21. Okay, this is the range. Okay, kilonewton per meter cube. Now gamma D falls in the range of what? It falls in the range of 17 to 19 kilonewton per meter cube. Right? Now you see, if it is 19 to 21, the gamma saturated, gamma submerged will fall in the range of what? If I subtract gamma W and suppose gamma W are taking 10 kilonewton per meter cube, right? It will become how much? 9 to 11, right? 9 to 11, right? And I can say this 9 to 11 is actually approximately half of 17 to 19, right? Yes or no? Yes or no? Yes. So therefore, I can approximate this in this manner, or I can say that the bearing capacity is becoming half na, from here to here. Or it will become double, na? Yes. So if you are moving from condition 1 to 2, means what? When the water is at ground level, to what? To great depth. Yes, to great depth. Then what is happening? The bearing capacity is becoming double, na? Yes, because here it is gamma submerged, here it is gamma D, so it is becoming double, right? Or I can say double means what? 100% increase, right? Means what? 100% increase. Yes. And when I'm moving from here to here, from great depth to what? To ground level. Water level is rising, right? In that case, what is happening? From 2QU to QU means what? 50% decrease. 50% what? Decrease. So remember this thing. They can ask a question like this. Now please write down this answer. I am writing something. Please fill in the blanks. And this is applicable for cohesion-less soil, because then only the first term goes away, right? So it's only depending on gamma, not depending on cohesion, right? So in cohesion-less soil, when water table rises from great depth to ground level, okay? Okay, somebody has written the answer also. the decrease in ultimate bearing capacity is, tell me what is the answer now? The decrease in ultimate bearing capacity is, please tell me what is the answer? The decrease in ultimate bearing capacity is how much? Arey, how much? I just wrote man and woman both. 50%. Yes, 50%, right? The decrease is 50%. That's what I wrote, right? Yes. Well, others are not answering. If I write down bearing capacity, suppose this is one type of question they can ask. The next type of question asking is what? Bearing capacity becomes des. Tell me, what's the answer? Bearing capacity becomes des. One is suppose half, second is what? 1/4, doubles, and suppose last one is none of this. What's the answer? Half. Very good. It becomes half. So remember this concept. Water table in cohesionless soil. Okay, water table in cohesionless soil rising from great depth to ground level, ultimate bearing capacity decreases to 50%, becomes half. Yes, and if the water table drops from ground level to great depth, then the ultimate bearing capacity becomes double. Yes, and it increased by 100%. So these questions are directly asked in your examinations as 1 mark question. Okay, these things are directly asked to you in the GATE 1 mark questions. So I have explained the concept behind it. It is only applicable for what? Cohesionless soil. Now answer this question. Now you answer this question. Now answer this question. Let us see how many are able to answer this fast. Now answer this question. Okay. Why are you taking so much time? Please read the question. Water table is at ground level, it is 660, right? Now water table is lowered. Okay. Water table is lowered, right? See, water table is lowered means what? Water table is lowered means what? It will become double, na? It will become double, na? Yes. So it will go from 660 to 1320. Just remember this simple fact. Water table is not good for your bearing capacity. Water table is not good for bearing capacity. Why it is such? Because see, when the water table rises, na, effective stress decreases. So effective stress decreases, that means what? The ultimate bearing capacity also decreases. So remember that. If you're confused that when it is half, when it is double, just understand that when the water table is getting lowered, the effective stress will increase, right? Because the pore water pressure will decrease. So what will happen? The bearing capacity will increase, means what? Becomes double. Understood this type of questions asked in cohesionless soil? Everybody understood? This is a very important question. Understood everyone? This type of question they will ask in the upcoming examination. Conceptual they will ask you, and it's a very important concept. Now they can frame many questions from this, but I framed one question. Very good. Let's go to the next question. Very good. Question number 4. You see, in 3 questions only we have covered so many things. Okay. Now this question you try. You first try, and then I will give the answer. You try first. What is written? The ultimate bearing capacity of a circular footing. Circular footing. Ultimate bearing capacity of a circular footing is given 332 kilopascal. Okay. And it is for a purely cohesive soil. Purely cohesive means what? C is equal to not 0, right? What is 0? Purely cohesive soil. Your phi is 0. and I have told that when it is purely cohesive soil, they will not give the value of NC and N gamma. Remember, NC is equal to 5.7 H per Tejagi and NQ is equal to 1 H per Tejagi and N gamma is 0. Okay, so write down the equation properly. Okay, equation properly. Depth of footing is given, unit weight of soil is given, and give me the cohesion value. Okay, let us see who will answer first. Let us see who will answer first and also correctly. That is very important, right? Okay, sometimes I'm seeing this side. You can see here actually all the comments are coming now. So there sometimes I will be seeing this side, so don't think that why sir is seeing that side. Okay, the comments are coming there. Write down the answer, solve the question and write down the answer. Come on. Okay, Rajsekhar is telling 52. No, no, no. Please see. Okay, 1928. How it can come 1928? They have asked only find out the cohesion. Cohesion they have asked. What you are doing? 40, very good Jeevan, very good Karthike, very good Vivek, very good, very good, very good. You see, you have to write down the equation properly, okay? Write down the equation properly. First thing is QU is equal to ultimate bearing capacity. It is circular footing, means what? 1.3 CNC plus QNQ and then what? 0.3, yes, B gamma, N gamma, very good. Okay, now what is happening here, you see, N gamma is 0, third terms goes to somewhere. Yes. Now this is equal to 1.3. C is, you have to find out. NC is what? Your 5.7. You have to remember this. That will they will not give. For purely cohesive soil, you took cohesion 332. Okay. See, for purely cohesive soil, NC they will not give. You have to remember this thing. Okay. Plus gamma DF. Gamma is how much? Gamma is 17.8. DF is 2. NQ is 1. So these two values you should remember. Okay, these three actually remember. Okay, so from here you can easily find out what the C and cohesion are getting how much? 40 kilopascal. Okay, 40 kilopascal. Very good. Okay, let us solve another question. Question number 5. You can see in 5 questions we have covered so many things. Now solve this question. I'll give you some time. Solve this question. I'll give you some time. Square footing. Okay. Placed on the surface. Surface means what? DF is equal to 0. Of a cohesionless soil means what? C is equal to 0. Has same bearing capacity. See, if they don't mention now which bearing capacity, take ultimate one only, okay? Has same bearing capacity as that of a square strip footing, which is also placed on surface and in same cohesionless soil. The ratio of their width, its arch. Okay, let us see who solves this question first. Let us see who solves these questions first. Okay, read the question carefully. You see, C is 0, DF is 0, means what? The first two terms goes away, right? So what is left is this. Rajsekhar, you have solved correctly. Just a minor mistake you did, I will tell you. But you have solved correctly. You have solved correctly, but a minor mistake you did, I will just tell you that what is the mistake. Don't worry. Okay? Nah. Others, it is 4 by 5 or 5 by 4? It is 4 by 5 or 5 by 4? Yeah, correct. Now Rajsekhar has corrected it. Yes. You see, many times in these questions of GATE and all, we get confused with, when they ask a ratio, then which ratio I will take? Square by strip or strip by square? That's a common doubt. See, they don't mention that which ratio they are asking. Always take the first term, means whichever term appears first in the question as the numerator. So they are asking what? QU of square. Okay, remember this. Whichever thing appears first, that's the numerator. Okay, divide by what? QU of strip. So you see, first and second term are not there, right? Because C is 0, DF is 0. Only second and third term are there. Only third term is there. So for square, it is what? 0.4 B, and I can say suppose square, then gamma and gamma, divide by what? For the strip it is 0.5, width of what? Your strip footing, okay, and then gamma and gamma. These two get cancelled. They have same bearing capacity, means what? This also gets cancelled. So from here, B of square by B of strip is how much? Is equal to 0.5 by 0.4 is equal to 5 by 4. You can see they are going to ask you such questions in the GATE examination. Can I say this question is actually one line? Can I say this question is actually one line, na? Yes. See, in GATE examination, 80% of the questions are one line or two lines. The thing is that you have to use the correct equation and the correct concept. And that you can only do if you have understood every concept from a proper teacher. Yes. Very good. Let us solve next question. Okay, question number 6. Okay, solve this question. I'll give you some time. Okay, solve this question yourself. So many things are given. I'll not tell the answer now. Okay, please solve this question. Last sector 200. No, 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 no. See, it's not cohesive, it is cohesionless. Some students are messaging me, sir, please finish the class before 7:30 because we have a match of India versus Pakistan. Okay, I'll complete before 7:30. Don't worry, we have more 40 minutes to go, and initial toss and all. So and there will be some initial overs. So I'll complete by 7:30. Even I also have to watch the match, right? Don't worry. 100, very good. Everyone, very good. You see, they have given what? They have given that we have two square footing, okay, okay, and both are having different diameters. Yes. So if I am finding the what they are asking, the ultimate bearing capacity of the second footing, which is diameter of D2. Now you see, for the D1 it will be how much? Again it is cohesionless. Again it is what? Cohesionless. It is cohesionless. And then second thing is what? It is placed on the ground level. It is placed on the ground level. Then what will happen? It is cohesionless and placed on the ground level. So what will happen? Then in that case I can say Q1, I can suppose Q1 will be how much? It will be equal to 0.3 D1 gamma and gamma. And Q2 will be how much? Same, 0.3 only. Then D2 gamma and gamma. Why? Because you see DF is 0 and C is 0. DF is 0 and C is 0. Okay. Now if you take a ratio of this, everything will get cancelled. Like at what? D1 by D2. Now D1 by D2 is 2. Yes. Q1 is 200. Right. So from here I can find out what? Q2. Right. And Q2 will be how much? Q2 will be 100 kilopascal. Very straightforward question, but you see how beautifully the question is framed. Actually framed by me only. All these questions are framed by me. Okay. Originally framed by me. Okay. Let us solve another question. Answer this question if this term is cohesive. If it is purely cohesive, then what will be the answer? Tell me. Let us see how many answers. If it is asked purely cohesive soil, then what will be the answer? In purely cohesive, purely cohesive. Purely cohesive. Purely cohesive. Very good, very good. See, if it is purely cohesive, then what will happen? Then the ultimate bearing capacity will be 1.3 CNC plus Q, because NQ is 1. NQ is 1 for purely cohesive and N gamma is 0. So this will be the term, right? This will be the term, right? And then It is placed on ground. Placed on ground means what? Q is 0, gamma df is 0. That means you can see it is 1.3 CNC and NC is 5.7. NC is what? 5.7. So you can see that this is independent of what? It is independent of size, right? You see, it is independent of your size and depth. Understood? It is independent of size and depth. Yes? So if it is a purely cohesive, then it will not change. It is not depending on the size of the footing. Very important point, right? It is purely cohesive. It's not depending on the size of the footing. So in the examination, if they ask a question like this, so please be little careful and see that it is written purely cohesive or purely cohesionless. You can see that many things change, right? Yes, good, good. But many of you caught the thing very nicely. Let us go to the next question. Question number 7. Okay, question number 7. Okay. So this question we will solve. This question we will solve. Okay. How to solve this question? I'll give homework. I will give you, let us solve this question. It's a good question. It's a good question. Okay. It's a good question. It will take some solving, but easy. A footing of 1.5 meter diameter, so diameter is a circular footing, okay, has a safe load of 1100 kilonewton, okay. In a cohesionless soil, C is 0. Unit weight of soil is given gamma. Determine the depth of footing for factor of safety 2.5, okay. NQ is given, N gamma is given. See, NC is not given because cohesionless soil means what? First term is not important, C is 0, so they have not given NC, okay. Now, when I write safe load how I will get? I will get by multiplying the safe ultimate bearing capacity into area of footing, right? So from here, I can find out the safe ultimate bearing capacity. It will be how much? It will be the load divided by the area. Area will be how much? Pi by 4 into 1.5 square. So if you find this, the safe bearing capacity, load by area, load by area, load by area, I am getting a value of how much? 622.5 or 622.5 kilo Newton per meter square. So this is the safe ultimate bearing capacity. Now safe ultimate bearing capacity is what? Safe ultimate bearing capacity is net safe plus gamma df. And what is net safe? Net safe is the net ultimate divided by factor of safety plus gamma df. And what is your net ultimate? It is your ultimate minus gamma df by factor of safety. And then we even have what? Gamma df. So indirectly what is written here? Indirectly it is written that QU minus gamma df means what? Net ultimate divided by factor of safety means what? Net safe plus gamma df is equal to how much? Is equal to the safe bearing capacity of 622.5 kilonewton per meter square. Very good. Very good. Now see the ultimate bearing capacity. C is 0. C is 0. So I am left with the second term and third term, right? So second term will be how much? Second term will be gamma df. Yes, gamma df into what? Into your NQ. NQ is how much you see? NQ is 49.38. NQ is 49.38, right? And then the second term will be what? It's a circular footing, means what? 0.3, right? Then diameter into gamma and then N gamma, right? N gamma is how much? It is given 54. Given about 54. Now this minus gamma df divided by factor of safety, which is how much? 2.5 plus gamma df is equal to 622.5. Now you see, we know the depth of footing, right? Depth of footing is given how much? Depth of footing is given as, that is we have to find out. Sorry. We have to find out depth of footing. Okay. Depth of footing you have to find out. Gamma is given how much? Gamma is given 17. Gamma is given how much? 17. So I'll put this. You see this is 17. Okay. Diameter is 1.5. Again gamma is 17. The only unknown term is what? depth of footing df. Can you find out the depth of footing from this equation? Yes. Please solve and give me the depth of footing. Okay. So 17 into depth of footing into 49.38 plus 0.3 into 1.5 into 17 into 54. Okay. Divided by 2.5. Again we have another subtraction, minus gamma df. Okay. And plus we have again on gamma df, right? So this plus gamma df plus is equal to 622.5. Actually you can do one thing, you can multiply 2.5. So this becomes what? 2.5 gamma df, and then you can take what? Whole divided by, right? Yes. Or you can add here what? 2.5 gamma df. Okay. Now give me the answer to this df. Let us see how many are solving this question. I'll also solve what? The first term you can approximate to through 839.5. 839.5 df. Okay. The second term will multiply 2.5 into 17. Okay. 1.39 meter. Okay. Very good. Some people have found out. Let me just check the values. 42.5 gamma df. 42.5 and then subtract 17. I am getting 25.5 gamma df. And this term will become 0.3 into 1.5 into 1.7 into 54. Solve it systematically. Okay. Solve it systematically. So it's getting 41.31. So this is equal to, I'll multiply 2.5 that side. So this will become 622.5 into 2.5. So 622.5 into 2.5. Okay. That is 1556.25. Almost everyone is getting the same answer. Okay. 1556.25. Let me just check this value of 0.3, and then diameter is 1.5 into 17 into 54. This I am getting is 413.1. Okay. So from here 839.5 plus 25.5, I am getting 865. Very good. Okay. And then 1556.25 minus 413.1, I am getting this as 1143.15. Okay. So now you can find out 1143.15 divided by 865. I am getting a value of, I have done some mistake. I have done some mistake. Okay. I have done some calculation mistake somewhere. Okay. But most of you are getting in the range of how much? I can say 1.4 meter, right? I am getting 1.3 meter. Anybody getting 1.35 meter, something like that, right? Okay. So most of you might have done some approximations. So we'll get in the range of 1.36 to 1.43, depending upon what is the approximation. And in GATE examination, they will give you the range, so no need to worry. Okay. In the GATE examination, they will give you the range, no need to worry. Okay. So understood this type of question which they ask in the GATE examination. Everybody understood how to solve these questions? Everybody understood how to solve this kind of questions? You see, the key is to write down the equation rightly, right? See, after that it is calculation. Yes, that can be improved. But the key was to write down the equation properly, right? The key was to write down the equation properly. You should know how to find out the safe, safe ultimate bearing capacity. The equation should be very clear. And if the equation is clear, then rest thing is what? Rest thing is simple calculation. Rest thing is simple calculation. Okay. And in calculation, you can do some approximations. Why I told? Because in the GATE examination, if they give you options, then they will not give you so close options. They will give you different options, like they will give you 1.1 and 1.7, 2.1. Okay. So then you can easily guess that which is the right answer. Or if they give you a range also, right? Means the numerical data entry type of questions, in that also they will give you a range. So no need to worry that, sir, I am getting a 1.38, somebody is getting 1.41. So, there will be some negative marking. No, don't worry. Okay. Because 1.38 and 1.41 or 1.42, it falls in the same range. Okay. Okay. Let us solve the next question. So this was the end of what? This is the end of your Terzaghi theory. We studied all everything is what? Terzaghi. Let us see something on Skempton. Let us see something on Skempton theory. Something on Skempton theory. So, Skempton theory. Now, what Skempton told? Skempton told that my theory is applicable for what? It is applicable for your purely cohesive soil. Okay, first thing is that Skempton told that it is applicable for purely cohesive soil. What Skempton told, before that let us revise what Terzaghi has told. So Terzaghi has told that the net ultimate bearing capacity, remember the net ultimate bearing capacity for a purely cohesive soil is what? Is equal to C and C, right? Why? Because for a purely cohesive soil, NC was 5.7 and NQ was 1 and N gamma was 0. So if you take your QU, it will be 5.7 into C plus Q. And if you take net ultimate, then what I will do? Ultimate minus Q, this becomes what? Only 5.7 C. Only 5.7 C, you can see what? NC into C. Now this is for a strip footing. This is for a strip footing, right? Now this will become what? This will become 1.3 C NC for a square or circular footing. Now this is as per whom? This is as per whom? This is as per Terzaghi. This is as per whom? This is as per Terzaghi. Okay. So Skempton told that I will also give my theory so that you know after 50-60 years some people will tell my name also. So Skempton gave his theory and Skempton told that the Q and U will always be C and C. It will be always be C and C. Okay. Let that be strip, square or circular. But this NC equation will change as per the shape and depth of the footing. Let us understand that. Let us understand that. So Skempton told that if the depth of footing is 0, means what? The footing is placed on ground level, right? If the depth of footing is 0, it is placed on ground level. Okay. Then Skempton told that your NC will be equal to 5.14 if it is a strip footing. Okay, and NC will be equal to your 6.2 if it is a square or your circular footing. Now this same thing was told by another scientist known as what? Prandtl. Okay, the same thing was told by another scientist called Prandtl, so I can say it got validated. Q net of Q ultimate, sir. What you are telling? This is net ultimate. We call it as what? Net ultimate. Okay, what? Net ultimate. Okay. Now, this thing is what? The depth of footing is what? 0. Now, then Skempton told that when the depth of footing by the width of footing is not 0, but it is less than equal to 2.5. Yes. Good evening, Prem. So, less than equal to 2.5. Now, what Skempton told in that case, that NC will be equal to, remember for rectangle, then you remember for everything. Now, many people get confused with Skempton's equations, okay. So, I will just make you remember one equation. From that one equation, you can remember other equations. Let us see what's the equation. The equation is 5 into 1 plus 0.2 B by L 1 plus 0.2 df by b. Now this equation is given for rectangular footing. You see, it's very easy to remember. How? See, 5. Remember 5. Okay. Then you see 1 plus something. Here also 1 plus something. Right? Now 1 plus something is what? So question is directly net ultimate, so no need to subtract gamma df. No. Direct formula. Direct formula gave by Skempton. Then you see 0.2 here, then 0.2 here. Okay, then two ratios, B by L, and here is what? df by b. Able to remember this equation or not? Able to remember this equation or not? Yes? Able to remember this equation? Yes. This is the grand equation, I can say, for what? For your Skempton theory. Okay. Now from this equation, we'll see many equations. How? You see? From this equation, I will tell that, okay, from the equation I will tell that, you see, NC is equal to 5, 1 plus 0.2 B by L, then 1 plus 0.2 df by b. See, if it's a strip footing, then what will happen? Your b by l is 0 na, because your length is so large. We have discussed this thing, right? Yeah, you have to remember this. Yeah. That's what I am trying to, see, that's what I am trying to make you remember, how to remember. You remember this one equation, okay? You remember this one equation, then print this one equation, how to remember other equations. That only I am trying to explain to you. See, strip footing means what? Length is large, so b by l is 0. In this equation, if b by l is 0, then what will happen? NC will become what? 5, 1 plus 0.2 df by b, right? Because you see in this equation what will happen? The first term 1 plus 0.2 into 0 means what? Only 1, right? Now this equation for square and circular. For square, b is equal to l, right? Or I can say b by l is 1. The equation becomes what? The equation becomes NC is equal to 5, 1 plus 0.2 b by l, and then 1 plus 0.2 df by b. Now if b by l is 1, then it becomes what? 1 plus 0.2, 1.2 into 5 makes me what? Gives me what? Gives me 6. The equation changes to what? The equation changes to NC is equal to 6, then 1 plus 0.2 df by b. So tell me, you have to individually remember for strip, circulars and square, or only remember for rectangular? Tell me what to do. What is the smart way? What is the smart way to remember? Tell me. What is the smart way to remember? Tell me. Only rectangle. Remember for rectangle, for square, and I can say circular or strip footing, directly find out. Right? Now this equation, I told it is for what? df by b less than equal to 2.5. Means what? For shallow foundations. Now for deep foundations, what happens? df by b becomes greater than 2.5. In that case, how to remember the equation? Very easy. If it is greater than 2.5, na, just put df by b is equal to 2.5. So if you put this df by b is equal to 2.5 here, so what happens to NC for a strip footing? If df by b is 2.5, how much value you are getting? Tell me. How much value you are getting? Tell me. Have to be smart. Tell me, if df by b is 2.5, how much value you are getting of NC? $7.5. Very good. Very good. And if you put 2.5 in this equation, how much NC you are getting? If you put 2.5 here, how much you are getting? In case of square or circular footing. This is for strip, you got 7.5. That you're getting how much? 9. And therefore, if you remember in pile foundations, for pile foundations, when I'm finding the ultimate pile capacity, I take NC is equal to what? 9, right? Why I take 9? Because there the pile shapes are what? Either they are square or circular. And therefore, I take NC is equal to 9. Now, many people would have got this understanding today first time, right? Many people would have got this understanding first time. Now, you see how by smart studies, actually I remembered one equation only. And then I am able to remember many equations. Yes, you see I have put 2.5, so what will happen? Become 0.5. So 1 plus 0.5 is 1.5. 1.5 into 6 will be 9, right? So remember only this equation, right? I can say remember only one equation. For rectangle, your NC is equal to, as per Skempton, 5, 1 plus 0.2 b by l, then what? 1 plus 0.2 df by b. Yes. For strip footing, yes, this will become what? 5, 1 plus 0.2 df by b, right? And for square and circular, it will become what? NC is equal to 6. Why? Understood? I understood. You see, now it is easy to remember, right? Now it is easy to remember, right? And then this is when the df by b is less than equal to 2.5. Means what? I can say swallow footing or shallow foundations. And df by b is greater than 2.5. Put 2.5. Put 2.5. So NC becomes what? 7.5. Here NC becomes what? Your 9. See, you're able to remember actually 4 more equations from one equation. Okay, so whole Skempton you can remember from this. Whole Skempton you can remember from this. Yes, how? You see, if I'm telling df is equal to 0, so what will happen? The second term will vanish, right? If df is equal to 0, the second term will vanish. And then for a strip footing, what happens? For a strip footing, what happens? B by L is how much? 0. So I get only 5 now. I get only 5 now if df is equal to 0. You see, only 5. Okay, only 5. But as per Skempton, it is not 5. It is 5.14. Little more than that. Okay, this 5.14 is actually pi plus 2 na. Yes, it is actually pi plus 2. Right? Pi plus 2 as given by your Skempton or Prandtl. Same thing they have told. Okay, so if you put df 0 and b by l 0, you will get 5, which is close to what? You can remember, right? See, the actual answer is 5.14 only. The actual answer is how much? The actual answer is, I have explained first initial part, I told 5.14. The actual answer is 5.14. But if you are forgetting that value, if you get a 5, you remember, na 5.14. Yes. And then if you see, for a square or circular footing, what will happen? df will be how much? Sorry, b by l is how much? 1. Yes. So I'll get 6 into, and df is 0, means I'll get what? Only 6 na? I get only 6. But the Skempton told is not 6 exactly, 6.2. Understood how you can remember? How you can remember 1, 2, 3, 4, 5, 6. All these 6 you can remember from this one thing, right? Yes, all the 6 you can remember from this single thing, right? Yes, that is smart studies. Always be smart. In GATE, you have to be smart. Okay? And anyhow, all these equations can be directly asked in the any exam also, right? Okay. Now solve this question. Now solve this question. Come on. Solve this question. So I have combined 2 theories. I have combined Terzaghi also. I have combined Skempton also. Okay, let us see who solves this question first. I'll give you some time. So solve this question. So 8 minutes to go for the match. Let us see, we will be able to complete or not. Yes, but we will complete, don't worry. But don't be any hurry, plus solve the question. You can watch the, you can mute the TV and, and watch the lecture for some time. Who is betting first? Let me see the score. Not score, means who is betting first. Let us see. Okay, so India is betting first. Okay, interesting. What are the lineups? I am giving you live updates also. Okay, we have an interesting match. Okay, Sekhar is answering 403.5. Okay. See, as per Terzaghi, it is 445. Now, as per Terzaghi, the net ultimate is how much? It is C and C. But it is not a strip footing. It is what? Circular footing. So it will become how much? It will become 1.3 C and C. Okay. And this will become what? 5.7. NC is 5.7. So this become how much? 7.41 C. H per Terjagi. H per Terjagi. Now H per Skempton. Now H per Skempton. This net ultimate will be how much? It will be your CNC only. It always remains CNC. Only the NC will change H per the shape and all, right? Okay. So here it will become how much? NC will be how much? NC will be equal to, it is a square. So circular means what? Your 6 into 1 plus 0.2 df by b, right? Right? Why 0.2 df by b? Yes. Why 0.2 df by b? Because you see your circular, or I can say square, I told that b by l will be equal to 1, that becomes 6. But again it is placed what? Footing is placed at surface. When placed in surface means what? df is equal to 0. So directly you should remember df is equal to 0, circular or square footing, NC is how much? 6.2, right? Yes or no? Are हाँ या ना? Yes. So directly it is 6.2 C. So what you will do? You see this is given how much? 445. So 445 by suppose this I am telling as X. H per Skempton. Okay, this is 7.41 C. This is 6.2 C. C get cancelled. This X, how much I am getting? This X I am getting is 6.2 into 441 divided by 445, sorry, divided by 7.41. I'm getting 372. Yes, 372.33. Understood what mistake you committed? Tell me what mistake you committed. You might have taken only C and C, na? You might have taken only C and C for what? Terjagi. I think so. I think so. Everybody understood this question? Everybody understood this question? Yes or no? Any mistake you have, what mistake you have done, tell me. And why you were not able to solve this, please tell me. Please tell me what mistake you did. I want to know. I want to know what mistake you did so that others can also understand from a mistake and don't do that mistake. Please write in the comment section what mistakes you did. So in this in this question, I wanted to explain difference between Terjagi and Skempton. Write down na. Yes sir, yes sir. Write down what mistake you did and why you are not able to solve. I am little strict teacher also. 1.3 not taken. Yes. Yes. Yes, yes. So remember, Terjagi, I will just summarize it. Remember, Terjagi, it is CNC for strip footing. Okay. And then 1.3 CNC for your circular or we can say square footing. But as per your Skempton, it is always CNC. Okay. Only this NC value changes as per what? The shape and other things. And here NC is always 5.7. Understood? The difference between Terjagi and Skempton. Yes. And here NC, how to remember NC? I have given everything here. Okay. So very good. Thank you very much. Now solve this last question. Question number 9. Actually, we have solved many questions actually. Solve this last question, question number 9. Okay, we have to find the value of NC. Okay, H per Skempton theory. They can ask this such kind of 1 mark questions also. Please find out. Everything is given. This is the width of the rectangular footing. This is the length of the rectangular footing. Yes. This is the depth of the rectangular footing. Please find out the answer. Let us see who finds out first. As I told, always remember the rectangular footing formula for Skempton. That formula, let's put the values. 2, 3, 1.5, 2. How much is NC? 6.516C. 6.516C. Understood? Understood? Okay. So I can say your NC, sorry, only this much, okay? So this is your value of NC. So such kind of questions they can ask from Skempton and from Terzaghi. Now, everything obviously we cannot solve within 1.5 hours, okay? So I have made you understand some of the basic concepts and the prominent questions which are asked in the bearing capacity of foundation engineering, okay? Now, many questions I have solved in another lectures of bearing capacity of soil, okay? You can search this lecture. This lecture is available on our YouTube channel, okay? On our YouTube channel, okay? You can search this lecture, okay? These are the keywords you can see. This is the heading of the particular lecture, okay? I have taught bearing capacity. You can see it is 1.5 hour lecture. I have completed many of the concepts and also the effect of water table. You see in this question, in this particular you can say lecture, I had some touch of what? Effect of water table. And more I have taught in this particular lecture on bearing capacity of soil, okay? 2 into 3 means what? The lesser one will be the width. See, whenever the writing 2 into 3 means what? Lesser one is width, na? The lesser one will be width and the longer one will be the length. Understood? So more lectures I have completed, okay? More type of questions I have completed here, okay? So you can visit this particular lecture and you can revise and solve more questions, okay? Also, on our BYJU'S Exam Prep official app, okay? I have taught whole geotechnical engineering in 156 videos. So you can visit that particular app in the Geotechnical, okay? Go to what? Learn with video lessons. In that, go to Geotech, okay? Geotech, and then go to Cello Foundations. In Cello Foundation, you can see I have solved many questions. You can see effect of water table, Satyajeet theory, numerical sessions, then Skempton theory, Marov theory, eccentric loading, okay? Please solve it. How to take dimensions for rectangular footing. I told na, the lesser one is the width, the longer one is the length. So if they write 3 into 4, this is width, this is length, okay? They write 4 into 3, this is width, this is length. The longer one is the length and the lesser one is the from foundation, length is less and width is, sir. No. Width is always less. Understood the concept or not? Width is always less. Therefore, it is known as width. Understood? Therefore, known as width. So they give a dimension 3 into 4. The lesser one is the width. They give 2.5 into 4. Lesser one is width. 4 into 2.5. 2.5 is the width. Understood, Jivan Prakash? The lesser one is the width. Okay. So, as I was explaining here, okay, so in our BYJU'S Exam Prep official app, okay, download the app, okay, in the Play Store you can download the app, okay, there you can go to learn with video lessons and you can see in Geotechnical I have taught all these lectures in details, okay, you can see from there, okay. Then homework questions. Now what? Homework questions. So I will give you two types of homeworks. I'll give you what? Two types of homeworks. The first one homework will be to read, okay, visit a lecture, read that particular lecture means what? Attend the lecture and then solve some questions. That is what? The pile foundation. The question number 10 is on circular pile foundations. This is your homework question. Okay, homework question, circular pile. And then another question I've given from circular pile, a group pile. A group pile. I've given what? Group pile. Okay, so these two are your homework questions from your pile foundations. And how to solve these two questions from pile foundations? Okay, you can visit this lecture, the pile foundation in clay. Okay, in pile foundation in clay, you can search this lecture on YouTube. Okay, it's available on our YouTube channel. So there I have taught you pile foundation in details, all single pile and group pile in clay. Okay, you can visit that lecture, complete that lecture, and then you can solve two homework questions. Okay, so two homework questions which are given from pile foundation, you can solve after reading this particular lecture, not reading, attending the particular lecture. Okay, and then in our official app also, in geotechnical engineering, I have taught pile foundation. You can see group pile in clay, there are numerical sessions, okay, then piles in sand, negative skin frictions, all the important topics I have taught in the official app also, okay. So thank you very much. Apart from that, whatever I have taught today, based on that, I have framed three questions. Question number 1, okay, question number 2, and question number 3. Okay, so lot of questions, okay. So lot of questions, a lot of homeworks for you, Okay, the last question is also an MSQ also. Okay, so solve these questions. Hope you enjoyed this particular lecture. The time is 7:33. I think Rohit Sharma has went on to bed. So let us enjoy the match. Okay, enjoy the lecture. Let us enjoy the match. Okay, thank you very much. And then I will be coming with surveying, steel structures and transportation, hydrology, irrigation. Okay, so if you want the notifications, I will suggest that subscribe to the YouTube channel. Okay, like this particular video and subscribe to the YouTube channel. Like the video and subscribe to channel, and also you can join the Telegram group. The link of the Telegram group is mentioned in the description. If you join the Telegram group, you will get a notification. You will get daily updates. Means what? Daily which lectures are being conducted, yes, and then what are timings and all, and the links you will get in the Telegram group. Okay. Thank you very much. Tata, bye bye. Okay. I have to go and stop the video. Okay. So I will first time. For reasoning doubts, can we join? Yeah. In a Telegram channel, not only civil lectures are going on, other lectures are also going on aptitude and mathematics and all. So everything is going on. Okay. So so I will bid farewell. And okay. Thank you very much. Bye bye. Okay. Thank you very much. Bye.